I was just at home distributing candy. If you're 17 years old, you should not go trick-or-treating anymore. My lesson from last night. So speaking of candy, I got extra candy from trick-or-treating because I'm the kind of person who buys too much because I'm always living in total fear that I'm going to run out of candy. And so I wanted this, and now it's time for my annual post-Halloween efficiency lesson. Okay, so we're going to talk about efficiency and equity. So if I wanted to distribute this candy equitably throughout the classroom, someone raise your hand and tell me one way to equitably distribute your candy. Yeah.
Throw it.
Throw it out. That's perfect, right? It's random. Some of you would get it, some of you wouldn't. I'd be a totally equitable way for me to throw out candy. And in fact, there isn't even enough candy for everyone in the class to get a piece, so some people would get one and some people wouldn't. So after I'd thrown the candy, some people would say it wasn't fair because some people would have gotten it and some people wouldn't. But before the candy was thrown, I think we could all agree that that's a fair way to do it. So that's a reasonably equitable way. I support that. Okay, so what would it mean to distribute the candy efficiently? What would it mean for me to distribute the candy efficiently? Pardon me? Okay, let's do a thought exercise. So this is the lesson. All right, so, all right. Would any of you on the first row be willing to pay more than a penny for our Reese's peanut butter cup? How much, okay, so out of curiosity, how much would you be willing to pay?
25 cents.
25 cents. Okay, so let's suppose that this is the only candy bar this is the only piece of candy I have. I could give it to you for 25 cents. Now we can ask ourselves, was that efficient? Don't eat it. We could ask ourselves, was that efficient? Is there anyone else in this classroom who values this candy bar for more than 25 cents? 50 cents. All right, there is. There's someone over there, so sorry.
75.
That's not efficient. We'll come back to your point in just a minute. Okay, so now, so how much are you willing to pay for it? $1? Are you kidding me? $1. All right. So we could get, and I can give it to you. I'll let you keep it. We could go like that. Go ahead. We could keep going like that until. But the idea is, if I only have one candy bar, the efficient way to do it would be to. No, hold on, I'm not quite done yet. So don't eat it yet. So, the most efficient thing would be for me to give that one candy bar to the person in this classroom who values it the most. That would be efficient. Now, remember the definition of efficiency, and I don't know if we've talked a lot about this, but the idea of efficiency is that if this, let's go back to this, when I gave him the candy bar, we said it wasn't efficient. So what does it mean for this to not be efficient? That means that there's some alternative way for me to rearrange resources in a way that makes everyone better off without hurting anyone. Now, when I took this candy bar away from you and gave it to you, it made you better off, but it made you worse off.
I felt sad.
He felt sad. He felt 25 cents worth of sad because he told me that's how much he was willing to pay this candy. So what's a way that we could rearrange things so that you're both better off? It's not splitting it in half because you value this at $1. You told me.
Yeah. Or she can give me whatever she paid for it.
You could give him some money. Okay. You could give him 25 cents. He'd be just as well off as he was before he got the candy bar. And I could give you the candy bar and you'd be 75 cents better off, okay? Because you would have gotten the candy bar that you value at $1 minus 25 cents you gave to him. So we could make everyone better off. So whenever an allocation is inefficient, it means it's possible to rearrange things in a way that makes everyone better off. Okay, so since you guys have been such good volunteers, I'll give each of you guys a candy bar because it seems like that's the only fair thing to do. But now let's suppose that I'm not done yet. There's more. I'll give you a read. There you go. All right, there you go. Thank you for volunteering. All right, but in general, if I wanted to distribute this efficiently, I wanted to distribute it to the people in this classroom who value it the most. Okay. Now, initially, he told me, so one option I could just say, just write down on a piece of paper your valuation for the candy bar. I'll collect all of them. I'll figure out who values these things the most. The number, there are 50 pieces of candy bars, or 50 pieces of candy. I'll just figure out the 50 people who value the candy the most, and I'll distribute it to them. Let's suppose I describe that as an allocation mechanism. How many of you would lie about how much you value the candy? probably a lot of you, right? Come here raising your hand. You'd say, I'd be willing to pay $10 for that candy. Because then you'd be one of the people who values it the most. So it's not really going to work for me to just ask you how much you value the candy. What's another thing I could do? How about I sell the candy? What if I charge a price for it? If I charge a price for it, and I really make you pay for the candy, then only the people who genuinely value the candy above that price are going to buy it. And in that way, I can make sure that only the people with the highest valuation of the candy actually get the candy. That would be efficient. Okay? And that's part of the reason why we think markets are efficient. Okay? Because when I charge a price for something, only the people who value it the most get it. And that means that I would have maximized surplus. Does that make sense? Okay, so I don't know what to do with this candy because I'm not going to charge you money for it. So here's what I'm going to do. I'm going to leave it up here, and at the end of the class, you can come and get it. Now, here's another lesson about efficiency. Why would it be a good idea from an efficiency standpoint for you to only take one piece of candy? Yeah.
Everyone has to get one, so that more than one, so that one more person can be happy.
So what you said sounds a little bit like an equity argument, which is I don't want. So I agree that if you only take one, then somebody else can have one, and that seems fair. But efficiency is about something else. So why, from an efficiency standpoint, might I only want everyone to take one piece of candy?
So your marginal utility decreases if you get two.
That's right. Because every time your marginal utility from the first piece of candy is greater than the marginal utility from the second piece of candy. And so if I kind of think that you guys all have kind of identical preferences for candy, which you probably don't, but assume for a minute that you do, then everyone should only take one piece because that's going to help maximize the sort of total increase to surplus that I get from distributing this candy. That's also going to be efficient. Okay. So that's the basic idea. So a couple different lessons about efficiency here. Does anyone really want a piece of candy in their product? Yes, her. All right. Well, give one to the her guy up there. Okay, so that's really what I want to talk about with regard to efficiency. And actually this fits in really nicely to talking about consumer strength. Where you go? Okay. So anyway, the candy's up here. I'm assuming that people who want the candy the most are going to be the ones who are willing to come up to the front of the classroom to get it. So I guess that's kind of efficient. But here it is. Okay. So there's my post-Halloween efficiency lesson. So hopefully that actually did clarify what we mean when we talk about efficiency a little bit. And we'll get into talking more about efficiency in a couple weeks. Okay, so what I want to do now is finish up talking about consumer surplus. And then we're going to move into talking about supply. Okay, so I think you guys have seen some of these definitions before, but it's worth going over them again. So what is a buyer's reservation price? That's just the largest dollar amount a buyer would be willing to pay for a good or service. It's going to tell you something about a consumer's willingness to pay for a product. So, for example, your reservation price for the Reese's Peanut Butter Cup was 25 cents. Your reservation price was $1. It tells you something about your reservation price. Tells you your willingness to pay, and it's a measure of how much you value a good or service. Okay, so that's the idea. And again, we've talked about this before, but demand curves tell us buyers' reservation prices at different quantities. And we tend to think that those reservation prices as quantity, let me go ahead and show the demand curve in the previous slide, next slide I mean. We tend to think that your reservation prices are decreasing as the quantity increases because of this idea of decreasing marginal utility. Okay, so the more you have from a product, the less you value it. Okay, so what is consumer surplus? Consumer surplus is just the difference between a buyer's reservation price for a good or service and the price they actually paid for it. Okay, so when I gave you that Reese's Peanut Butter Cup, you valued it for 25 cents, you paid $0. Your consumer surplus is 25 cents. Your consumer surplus was $1. Okay, because you didn't pay anything for it, you valued it for $1. So that's how we figure out, that's the idea of consumer surplus. Graphically, when we talk about consumer surplus, often what we're talking about is the sum of the whole of the surplus that goes to everyone in the market. Okay, so in this case, we can, if this is the demand curve for this product, and the equilibrium price is given by P star here, then the equilibrium quantity is obviously going to be Q star. I'll go ahead and put that up here. And there's going to be some surplus that goes to everyone in this market who buys this product. Some of these people have a relatively high willingness to pay, and they're going to get a lot of surplus. The next person might have a slightly lower willingness to pay, they're going to get a little bit less. But all of these people, everyone who buys this product, is going to have some surplus, except for maybe the very last person who's probably getting exactly zero. If we sum up all of that surplus, it's just given by the area under the demand curve and above the equilibrium price. And this area is often what we refer to as consumer surplus. Okay, so it's just the surplus that goes to everyone in the market who buys a good. It's the difference between the amount that they value a product, which is given by the demand curve, and the amount that they pay for it. And we're summing it up for every single unit that's sold. Okay, so for every single unit that's sold, there's surplus that's associated with it. If there wasn't surplus associated with it, that person wouldn't buy it. Right? If I was charging $1 for Reese's peanut butter cups, you would not buy them. So every single person in this market, every single unit that's sold generates surplus. We want to add all of that surplus up, and all of that area is called sort of total consumer surplus in the market. Again, just sort of emphasizing some of the things that we were just talking about a few minutes ago when I was talking about Halloween candy. Sort of notice again that it's sort of people who value these products the most who end up buying them. Okay, and it's the people down here with a low willingness to pay who don't buy them. And that's going to maximize our total surplus. Okay. Questions about consumer surplus? I think you guys have sort of seen this in different forms, but now we're just presenting it again to make sure we're all on the same page. Yeah.
So if that equilibrium price, if their reservation price is below that, then they don't get counted into the consumer surplus.
Right. That's right. So this person, they got some value with the good, but they're not getting it. So they're not trading in this market. So there's no surplus that's generated. This market doesn't generate any surplus for them.
Okay.
It doesn't generate any loss either, but it doesn't help them.
Okay.
The last person to buy this product got some zero surplus, and all these people aren't buying it, so they're sort of out of the picture. But every single unit that's sold in the market is generating some kind of surplus. Okay. All right. So questions about this? Okay, great. So let's go ahead and move on to the next set of lecture notes, which are related to supply. So we've just spent a few weeks talking about demand and sort of really going underneath the demand curve and developing a model of how consumers make their choices. And now we want to develop a more specific model of how producers make their choices and try and sort of get underneath the supply curve and figure out where that supply curve that we were talking about in the earlier part of the quarter actually comes from. So our whole discussion of producers and of supply is going to be based on this assumption that firms are maximizing their profits and that their goal is to maximize their profits. And when I was an undergraduate and I heard this assumption, I guess I was kind of idealistic. I'm not anymore, but at the time I was, and I guess I sort of thought, well, aren't there firms that are trying to produce, eco-friendly products? It seems like some firms are trying to do something else other than just trying to maximize their profits. And I thought, well, does this contradict the basic assumption that they're making in all my economics classes that firms are maximizing their profits? And similarly, there are these firms that try to provide good working conditions for their employees. It seems like they're trying to do something other than just maximize their profits. So is this a valid assumption? And the answer is that it is. Okay, so the idea here with these eco-friendly products is that an eco-friendly product is a product, and if you're producing that eco-friendly product, you want to be trying to maximize your profits. Okay, so conditional upon producing that product, you want to be trying to maximize your profits. Why? Because if you're not, some other company is going to enter into the market and try and produce that eco-friendly product and sell it for less because maybe you're not producing things efficiently, and they could drive you out of business. Similarly, I mean, there are actually reasons, profit maximizing reasons why firms might want to provide good working conditions for their employees. This can actually be consistent with profit maximization. Why? Well, for example, it's possible that you'll get a better set of employees who stay at your firm for a longer period of time if you provide them with good working conditions and health benefits and stuff like that. And so firms it might actually benefit firms because they get a better workforce if they provide these better working conditions. But regardless, if firms are not maximizing their profits, there's going to be some other firm that's going to come into the market who's offering the same good working conditions who could drive that company out of business. Okay, and so firms are always going to want to try, they can produce eco-friendly products, they can try and provide good working conditions, all of those things are valid, but conditional upon doing all of these things, if you're a firm that wants to do this, wants to provide good working conditions, you've got to still be trying to maximize your profits. Because otherwise you can get driven out of business. And so this is always what firms are, profit maximization is always going to be part of what firms are trying to do. When we talk about profit maximization, there are really two sides of it. So let me just actually talk about what we think profits are equal to. Profits usually get denoted with the Greek letter pi, and they're equal to total revenue minus total cost. So there are really two sides to profit maximization. There's the cost side and there's the revenue side. The cost side is just simply how much it costs a firm to produce something, and that's very much going to be related to their production technology. Okay, to the cost of the inputs, to the process through which they transform those inputs into the output. Costs are going to be related to just production, like what it actually takes to make something. Revenues are just simply how much a firm can get from selling something. And this, it turns out, revenues actually relate to the market structure. And what do I mean by that? Well, in this class, in Econ 1, we're going to be looking at revenue when we're in a situation where we have perfectly competitive markets, where firms are competing with one another, where there are lots and lots of firms, and there's lots of entry into the market, and there's just perfect competition. In Econ 2, if you go on and take Econ 2, you'll learn about revenue in situations where markets are imperfectly competitive. So what revenues might look like, for example, for a monopolistic firm, where there's only one firm that's selling a particular good or service. So, for example, De Beers Diamond Company really dominates the diamond market. They are close to a monopoly, or they're less so now, but in the 1980s and 1990s, De Beers had close to a monopoly in the world diamond market. And so revenues are going to be different in a market that's imperfectly competitive, like the diamond market, relative to markets that are perfectly competitive. Okay, so in this class, we're going to be focused on revenues in markets that are perfectly competitive, and it actually turns out it's very easy to characterize revenue in these kinds of markets. So when we're just dealing with profit maximization, we're first going to talk about costs. That's where all the hard work is going to be. And then we'll move into talking about revenues, and that's actually very simple. And we'll put all of that together, and we'll be able to say something about how firms maximize their profits. Okay, so what I want to do now is I want to talk about the production side of the market. I want to talk about firms' production technologies because we really want to start to understand the cost structure of firms. So typically, when economists talk about the production technology, when we talk about production, we divide things into two time horizons. There's something called the short run, and there's something called the long run. Okay, so what is the short run? The short run is the period of time, these definitions are a little bit nebulous. It's the period of time sufficiently short that at least some of the firm's factors of production are fixed. What's the long run? That's the period of time sufficiently long that all of the firm's factors of production are variable. Okay, so what do I mean by this? Okay, so first of all, for a lot of the lecture when we're talking about supply, I'm going to be talking about a specific company. I'm going to talk about, it turns out my best friend owns a bakery. And that's a firm, and we can talk about that firm. The nice thing about a bakery is that the production technology is pretty understandable to all of us, because we all basically know, in some level or another, what it takes to make a cupcake or a cookie or something like that. So my best friend owns this bakery. I'm going to walk you through, I just want to give you guys all this sort of image or sort of a common understanding of what this bakery is like so that when we're talking about all this stuff, it makes sense. So my friend, it's a bakery cafe, You walk into the restaurant, I guess, and there are some tables and chairs there. It's the kind of place where you go up to the counter and you order your sandwich or your bagel or whatever. She's kind of a hippie, so everything's like organic and locally grown. That kind of place. You can get your Swiss chard quiche and that kind of thing. And then you go back into the kitchen, and the kitchen looks very much like you would imagine it to look like. There's a huge refrigerator unit. There are some ovens where the bread gets baked, big industrial-sized ovens. There are these amazing mixing bowls, like literally bowls that are this big with huge wands that come down and mix the dough. And then there are these big surfaces where the bakers who work there can sort of make the cinnamon rolls or roll out the bread or whatever it is that they need to do. And it's a relatively small operation. It's not it's not like a big industrial bakery. She lives in a small town. She's a little bakery in a small town. She's very successful, but it's not a huge, physically it's not a huge place. Okay, what are her inputs to production? Because in other words, what are some of her factors of production? I've already introduced this word, factors of production. Factors of production are just the stuff that you use to make your output. So in her case, the factors of production there are a lot of things. There's the oven, there's the refrigerators, there's the flour, there's the butter, there's the milk, there's the chocolate chips, there's all of the inputs to production. And there's also the lease on the building that she rents to make all of this stuff. Those are all the factors of production. So everything that she uses to make her bread and her baked goods and sell them, those are all the factors of production. Okay, so now back to the definitions. What's the short run in her case? The short run is a period of time sufficiently short that at least some of the firm's factors of production are fixed. Okay, so let's suppose that and it's true, she's got a kitchen of a fixed size. She's got a fixed amount of oven space. She's got a fixed amount of refrigerator space. There's a period of time over which she just simply cannot change the size and the size of the number of ovens that she has, the number of mixing machines she has, the floor space in the kitchen. Over a fairly decent period of time, those things are actually fixed. Okay, it's hard for her. It's going to take a long time. If she wanted to increase the number of ovens that she has or increase the floor space of her kitchen, that would be a lengthy process. Okay, she'd have to buy a new oven. She'd potentially have to move into a new space if she wanted to increase the size of her kitchen. So the period of time sufficiently short that at least some of the firm's factors of production are fixed, that's the short run. So if you think about the period of time during which she just can't change all of her inputs, all of her factors of production, that's going to be the short run. The long run is going to be a period of time sufficiently long that all of her factors of production are variable. So there's no specific calendar period associated with this, but for example, if in her case, in a matter of 2 years, if she could change all of her factors of production, she could move into a new kitchen, she could buy new ovens. If it took her 2 years to do that, then that would be the long run. That would be the period of time that's long enough that allows her to vary all of her factors of production. But what I want you guys to understand is that there are some factors of production that are easy to vary that are easy to change. For example, it's easy for her to buy more flour, it's easy for her to buy more chocolate chips. It's harder for her to change the floor space in her kitchen. That's going to be something that's harder to change. And so there's going to be some period of time in which some of the firm's factors of production are fixed, and there's going to be, it's going to take a longer period of time, the long run, that's the time sufficiently long that all of the firm's factors of production are variable. Now I want to give you guys some definitions. There's total product, marginal product, and average product. So I'm going to give you guys these definitions, and then we're going to work through an example that will help you understand them. So total product is going to be the total quantity produced at a given level of input. So how much the firm is actually producing, given what their inputs are. Marginal product is going to be the increase in total product given a 1 unit increase in a given input. So for example, if she hires another worker and she can produce 10 more loaves of bread, then the marginal product of that that additional worker is going to be 10 loaves of bread. It's the additional output that you get from an additional unit of the input. What's average product? That's just total product divided by the quantity of the input used. So all of this sounds relatively imprecise at this point. So let's go ahead and do a specific example. Okay. So let's let's just suppose that over here on the left, I have, let's say, the number of bakers or the number of employees she has working in her bakery, working in the kitchen. And the second column tells you the total product, the total number of loaves of bread that she can produce, let's say maybe every day, given the number of bakers that she hires. Okay, so this column here just gives you total product as a function of the number of workers that she hires. So here's our factor of production, this is our input, and here we have the total output. Now we can talk about marginal products, the additional output that she gets from hiring an additional worker. So when she goes from 0 to 1 workers, what's the marginal product? 15, that's exactly right. So the marginal product of the first worker is 15. What's the marginal product of the second worker?
25. 25.
So from 15 to 40, so the marginal product is going to be 25. What's the marginal product of the third worker?
23.
23, that's exactly right. And what about the fourth worker?
7.
And that's right, and the fifth worker is 5. Now let's figure out average product. Okay, so now you guys know the mechanics of figuring out marginal product. Let's figure out average product. Average product is just the total amount that you're producing divided by the number of units of the input that you're using. So you can talk about the average product of bakers. In other words, how much output do you get per baker that you hire? And so here, it's pretty simple. We're just taking the second column and we're dividing it by the first column. So the average product of the first worker is going to be 15. The average product of the second worker is going to be 20. And what do we mean by this? What we mean is that on average, when you're hiring 2 workers, each can produce 20 loaves of bread. Even though the marginal product of the second worker was 25, on average, the average product was 20. What's the average product of the third worker? That's just 21. The average product of the fourth worker is 70 divided by 44, which I'm having a hard time calculating in my head at this moment. I had too much candy. But whatever that is, okay? And the average product of the fifth worker is going to be 15. And I can still divide 75 by 5, despite the amount of chocolate I had last night. But 70 divided by 4, 17.7. Anyway, okay. So here's average product. Okay, so before we go on to the next slide, are you guys just sort of clear about the mechanics of how we're calculating how we're calculating marginal product and how we're calculating average product, and sort of what they mean? Okay, the marginal product tells you the additional output you get from hiring an additional worker, and the average product tells you, on average, how much output you get per worker. So slightly different concepts. Okay. Well, let's talk about some of the patterns that we saw on that slide. So one of the important patterns that we saw was that, and we'll go back to the slide in just a second, was that initially marginal product was increasing, and eventually marginal product was decreasing. What do I mean by that? So let's just go back to the previous slide and look at this, look at what I mean. So initially, marginal product was increasing. It went to 15, went from 15 up to 25, and then it started to fall. So initially, marginal product was increasing, and then eventually it started to decrease. Why do we think that that's the case? Well, the reason why we think that's the case, the reason why we think that marginal product is increasing initially is because of specialization. So what do we mean by this? Again, go back to, imagine you're in the bakery, and you've got one person working in it. That person is doing everything. They are washing the dishes, they are kneading the bread, they are whipping the cream, they're mopping the floors, they're doing everything. If they hire a second person, those two individuals can start specializing in doing what they have a comparative advantage in. The person who's relatively fast at doing the dishes can start doing the dishes. The person who's relatively quick at kneading the bread can start kneading the bread. And so the marginal product of that second worker is even higher, okay, because of this boost to productivity that they're getting because of specialization. But then eventually, obviously, the specialization factor has got to start it's got to start to fade out, because eventually we see that the marginal product is decreasing. Why do we think that happens? That happens because of something called diminishing marginal returns. Right? What are diminishing marginal returns? The idea here is that as a firm uses more of a variable input, in this case the variable input is the number of workers that they're hiring, with a given quantity of fixed inputs, okay, in the short run now, fixed inputs are going to be the ovens, the number of ovens, the floor space in the kitchen, all those things are fixed in the short run. The marginal product of the variable input of these bakers is going to start to decline. Okay, so imagine now you are in the bakery, it's a relatively small kitchen, one or two workers, yes, marginal product might start to increase, but now the kitchen is starting to get a little bit crowded. The ovens are full. There's only so much bread you can bake in the ovens at a given period of time. There's certain factors of production that are fixed. The floor space is fixed. The number of ovens are fixed. And so as you start hiring additional workers, there's less and less and less each additional worker can do because you're already using up all of your fixed inputs. There's just only so much more you can actually do. And you can almost imagine you get to the point where the kitchen is so crowded people can't even move. Okay, there's just so many workers in there that can't actually even do anything. Okay, and then the marginal product is going to be, could even go negative, but it's certainly going to get really, really small. Okay, and this is, again, because of this idea of diminishing marginal returns. When some of your factors of production are fixed, okay, when the floor space is fixed, when the number of ovens are fixed, the marginal product of that variable input, in this case the bakers, is going to start to decline. Okay, and it turns out that average product follows a similar pattern. So we saw that average product initially increased, and then eventually decreased. And the reasons for that were very similar. Okay, so again, we saw average product was initially increasing and eventually decreasing. So now we can draw the total product curve. Okay. So now this is a much more general representation of how we think of total product and what we saw in the previous couple slides. But again, we have labor here on this axis. Labor is often thought of as being one of those variable inputs, one of the things that you can really change in the short run. And we have output on the y-axis. And notice that as you hire additional workers, you're getting additional output. No problem. Okay, so you see as the number of workers goes up, the number of loaves of bread goes up. So output goes up. What I want to do now is talk about marginal product and draw marginal product on this graph or on this slide. So let's go ahead and talk about marginal product. So let's suppose that you hire one worker. We can figure out how much they're actually going to produce. Okay, so when you have one worker, the total product curve tells you output with one worker. I'll just call this little q sub 1. Now when you hire two workers, you can produce q sub 2 units of output. When you hire three workers, you can produce q sub 3. When you hire four workers, you can produce q sub 4, all the way up until we'll stop at 5 workers. You can produce q sub 5. So graphically, how do I find marginal product? Remember, marginal product is the change in output that you get from hiring an additional unit of your input. So when I go from hiring 0 to 1 worker, this distance right here, this distance between the origin and q sub 1 is the marginal product of the first worker. So I can go ahead and label that. So this little distance here is the marginal product of the first worker. Similarly, I can figure out the marginal product of the second worker. That's the change in output that I get from going from 1 to 2 workers. That's just the distance between q sub 2 and q sub 1. That's going to be the marginal product of the second worker. Similarly, I can say, what's the marginal product of the third worker? That's just the increase in output that I get from going from 2 to 3 workers. So this whole distance here, between Q3 and Q2, is the marginal product of the third worker. Similarly, I can write down the marginal product of the fourth worker and the marginal product of the fifth worker. What you can see, given the way I've drawn this picture, is that we have that the marginal product is increasing initially and eventually decreasing. So the shape, the reason why this curve, the reason why this total product curve has this particular shape to it is because it reflects the idea that initially we think that marginal product is increasing because of gains from specialization, but that eventually it's decreasing because of diminishing marginal returns. Okay, so again, here we have increasing marginal product, and up there we have decreasing marginal product. So this curve reflects all of that. What some of you are probably figuring out here, as you look at this, is that marginal product is basically the slope of the total product curve. And that initially the slope of this total product curve is increasing. That's representing increasing marginal productivity. And then it hits some inflection point. And from that point onward, the slope of the total product curve is decreasing, representing decreasing marginal productivity. Okay, so we have this increasing slope, and then we go to this decreasing slope. That's the basic idea here. And the way this was, somebody described this to me. I heard someone. This isn't necessarily a great example of what I'm trying to illustrate, but it did help me remember it. I heard a professor once lecturing about this topic, and he described this curve as being like your grade, your output there would be like your grade on your Econ 1 midterm, and your labor here would be the amount of time spent studying. He described it as follows. He sort of said when he was in college and he started studying, the first few minutes were just, even the first hour or so was like a waste of time. You're in the kitchen, you're making coffee, you're talking to your roommate about how much you paid Econ 1, you're updating your status on your Facebook page. That time that you're spending studying isn't doing much. And then all of a sudden you hit your stride. And you are studying, you are getting stuff done, you are learning, you are in your rhythm, things are going well. And then it's like midnight, it's 1 a.m., you're getting tired. Each additional hour that you spend studying is doing less and less and less to sort of improve your grade on your Econ 1 midterm. And so